The UnrealReader in Nuke 14 brings maps and sequences from an Unreal editor session directly into your workspace in Nuke. To install the Unreal plugin, please go to the Nuke UnrealReader section on the Foundry Learn Nuke page for more detailed information. Once installed, you can enable the Nuke server plugin and start a server in your Unreal editor session. Using the UnrealReader node, you can then connect to that session, choose a map and sequence to work with, and start asking for renders for particular frames in your chosen sequence. Using the node level controls in Nuke, you can request a number of AOVs to be generated, including Unreal's buffer passes and utility passes like scene depth and cryptomat data. You can also add custom Unreal post-process and class render passes in the Nuke server panel for use in Nuke, providing artists with an expanded set of render passes for greater control over their final look. All of these AOVs are generated on demand, so you only need to pull in the data that you need when you need it. You can have additional control over your render using the Advanced tab, which exposes Unreal render settings. Among the operations, you can choose from multiple cryptomat ID types to match your segmentation needs, or set your OpenColor I/O settings to ensure color consistency in your Unreal and Nuke pipeline. You can also synchronize a camera in Nuke with the camera in your Unreal sequence. This means that you can match the camera position in your Unreal sequence to Nuke's 3D space, allowing you to use projections and texture placement in Nuke's 3D system to augment your Unreal render. What's more, you can even override Unreal's render camera with one supplied from your Nuke script. So if you want to nudge a camera a few units to the right, or push in slightly, you can make that change in Nuke and get an updated render without having to go back to Unreal. This workflow is non-destructive, as it overrides the Unreal camera at render time without modifying the original Unreal scene. The UnrealReader grabs frames on demand from Unreal, but when you're happy with your settings, you can write an entire sequence to EXR, including chosen AOVs, and then automatically create a read node to view the results. Metadata from the Unreal level sequence actors is also included in the EXR render, allowing you to automatically drive settings into your Nuke composite, such as depth of field values, light positions, and axis nodes for reference. You can also add one of the many Unreal console variables and commands from the UnrealReader node to get finer control on the look and feel of your render. These allow you to control anything from bloom quality to shadow resolution. UnrealReader enables you to work in stencil layer mode, which allows you to isolate specific objects into their own render layers. This gives you the flexibility to generate mattes for specific objects, or to layer up objects piece by piece as you would do in a normal composite. You can view alpha from these layers, although Unreal does not render this information by default. For further information on enabling the stencil layer alpha setting in Unreal, please see the Nuke UnrealReader section on the Foundry Learn Nuke page. You also have the option to remove dynamic shadows and occluding objects from the selected layer, giving you access to scene information which doesn't exist in the final render. Stencil layer mode also allows you to request any of the usually available AOVs for each of your generated layers, so that you can isolate information like world position or world normal on your chosen objects in the scene. If you want to edit your Unreal scene, you can do so in the editor and simply fetch the latest from the UnrealReader node to see the updated render in Nuke. We've also included the ability to render your Unreal scene as a cube map. This allows you to convert an Unreal scene into a lat long or an environment sphere. You can generate cube maps using any of the available AOVs, meaning you could also do this in conjunction with the spherical transform node in Nuke for converting Unreal scenes into spherical environments, generating environment maps for use in the lighting department, or using the position data from Unreal to reconstruct the 3D scene in Nuke using position to points. With the ability to visualize your scene in a point cloud in Nuke, you can position your cards or add new lighting, which allows you to quickly create new iterations in the context of the final image. UnrealReader in Nuke 14 accelerates the pipeline for getting image data from Unreal into Nuke X, enabling you to combine the speed and efficiency of real-time rendering with the flexibility and fine-grained control available in Nuke's node graph.